This is 3.6 continued. I am on page 12. We are looking at right underneath example E, it says to calculate the derivative of a complex fraction involving product, quotient, and powers. We can often simplify the process by taking the logarithms. The process is called logarithmic differentiation. So give that box a star there, definitely something we should know. And this says logarithmic differentiation. Take the natural log of both sides of an equation, so again on both sides of the equation, and use properties of logarithms, those are covered in chapter 1, to simplify. Then differentiate with respect to x to solve for y prime. So the first example says use logarithmic differentiation to find the derivative of this function. Normally for you guys in the book, it will not tell you to use logarithmic differentiation. You need to recognize that on your own. So if you look at A and if you look at B, you'll notice that both of them have a base that involves our variable x, and they also both have an exponent that involves the variable x. And that's a good indicator that you're probably going to be using logarithmic differentiation because they are more complex. So we're going to go ahead and we would be stuck here trying to take the derivative. We can't use the power rule. We're really lost on whatever we could be able to do here. So we're going to try the logarithmic differentiation. It says to take the ln, the natural log of both sides, and on the right side we can simplify this a little bit using those properties of logarithms that are covered in chapter 1. And from here I don't have y by itself, so I am going to be dealing with an implicit function. In dealing with an implicit function, I need to use implicit differentiation. So the derivative with respect to y, the derivative with respect to x of ln of y is going to be 1 over y times dy dx is equal to, and taking the derivative here, we're going to have to do the first term times the derivative of the second term. The derivative of ln of x is just 1 over x, plus the second term times the derivative of the first. And again, our whole goal is to get dy dx by itself. So rewriting this, we can multiply both sides of our equation and simplify this, but multiply both sides by y. So we're going to have dy dx is equal to y times, this is going to simplify to 1 over the square root of x plus ln of x over 2 times the square root of x. Since these have the same denominator almost, we can combine them if you multiply this first fraction by 2 over 2. So I have dy dx, and your answer should be left in terms of just x's, since that was what our original function is. So I'm going to back sub in what y is, and we know that y is equal to x squared of x. So go ahead and see if you guys can look at B and see if you can use the same process to try to take its derivative of y equals cosine of x to the x power.